So we have two equal point charges, and we're gonna label this as Q. So we'll have plus 35 microcoulombs, or 3.5 times 10 to the negative fifth coulombs. At this point, we know that the work needed to move one of the charges is going to be delta PE equals PE final minus PE initial. And we know that the charge that we're trying to move is 5 times 10 to the negative 7th coulombs. So if we were to draw this, we can say that we have 1, 2. So this would be the original, and then after the displacement, we have this. So we have Q1, Q2, rather, Q1, Q1, Q2, Q2. We have Q here and Q here. So we know that this distance here is going to be equal to D, so 46 centimeters, or 0.46 meters. We know that this distance here is going to be 12 centimeters. So that's how much we're moving the point charge. And then the distance from here to here is going to be, of course, 23 centimeters. Not drawn to scale. I apologize. So at this point, once we have our diagram, we can actually start and say that the potential energy final is going to equal KQQ divided by D over 2 plus KQQ divided by D over 2. And our potential energy initial will equal KQQ D over 2 minus 0.12 plus KQQ divided by, then it would be D over 2 plus 0.12. So that would represent the moving the charge. So we know that the work is going to be equal to delta PE. So we can say it's going to be equal to KQQ I apologize, this will be final. And this would be initial. So this would be KQQ, and then it would be D over 2 plus 0.12. At that point, we can say that this is plus KQQ. We're simply taking this and subtracting this. So this would be D over 2 minus 0.12, and then we have minus 2 K. So that would be the final change in potential energy. Let's factor out some constants, and we have K, Q, Q. So this would be D over 2 plus 0.12 over 1 plus D over 2 minus 0.12, and then minus 2 over D minus D divided by 2. And at this point, we can actually solve. So work would be equal to 8.99 times 10 to the 9th, so Coulomb's constant, times 3.5 times 10 to the negative 5th, and then it would be 5 times 10 to the negative 7th. And then we have 0.35 plus 1 over 0.11 minus 2 over 0.23. Apologize for the, let me just fix that. Okay, and at this point, we can just plug this into a calculator, and we find that the work needed to move the charge is going to be equal to 0.512 joules. So essentially, you just have to find the change in potential energy from the initial state to the final state. And the change in potential energy would be equal to the work needed to move the charge. And again, that final answer is 0.512 joules. That's the end of the solution. Thank you for watching.